Okay, so welcome everyone to this webinar, Nordic Tech Webinars, Getting Started with NR PHY. I am Heidi Soli. I am a Senior Product Marketing Engineer here at Nordic Semiconductor, and I will be your host. And with me, I have Lauri Pikivi, who is the Technical Product Manager for DECT NR+, who will be giving the presentation, and then I will be doing a demo at the end. So some practicalities before we get started. This webinar lasts for 45 minutes. That's 30 minutes for the presentation and demo and 15 minutes for questions. Questions are encouraged. Please ask them throughout the presentation. To ask a question, please use the questions bar that you'll find at the top right panel, not the chat, where you guys are all writing your hello messages, but please ask questions in the questions panel. Try to keep them relevant to the topic, and then we will answer them towards the end. So the chat is not anonymous, so do not use that for questions, but use the questions panel. And then if you have any more questions after the presentation or your question doesn't get answered, you can always go to DevZone to have your question answered there. And a recording of the webinar as well as the presentation will be available together after this webinar at webinars.nordicsemi.com. And with that, I will just hand it over to Lauri.
Thanks, Heidi. So the agenda for this presentation and demo is the introduction of the NR Plus, and we wanted to show what is now readily commercially available from Nordic for this technology. So we will go through some of the basics of the NR Plus as a reminder, or if you haven't gone or seen the presentations from Nordic or from the DECT forum that are available on the web on this technology. Then we go through what we have on software, hardware, some words about the regulation on the radio bands, then the live demo, and in the end, the questions and answers. So what is NR Plus? Introduction and a very, very brief overview. So NR Plus is a radio technology that has been defined in the DECT forum and DECT working group in ETSI standardization. It is made to operate primarily on the DECT band. So DECT is this technology that has been around from the 90s for cordless telephones and enterprise telephone systems. And it has a radio band allocation. And there is not that much use now with digital audio and so on that band. And it was seen as a place where new technology can be introduced to better utilize that radio band. Radio band is the modern oil. That there is always more demand for radio band. But NR Plus, it's a new standard, so it's been publicly available from end of 22. So it does utilize the modern technologies, OFDM, some fancy modulation, forward error corrections to make it really operate reliably or fast, depending on the application need. But the main benefits, of course, is the band, license-free band, especially here in Europe, where let's say a radio band usable for IoT applications is hard to find. There is the ISM band 2.4 gigahertz, which is kind of full with wireless LAN and Bluetooth and other technologies. And then there are very narrow bands in the sub-gigahertz space. So this DECT band around the 1.9 gigahertz 20 megahertz band in total in Europe is very good for the IoT usage that is increasing in the world. About the speed and latency, so the speeds that we can now reach with our offering on the hardware and software is up to 3.4 megabits per second. The standard itself goes way beyond that, but that requires access to some radio bands that is still under standardization, for example, around the 3.8 gigahertz space. But what we can now achieve on the 1.9 gigahertz band is 3.4 megabits per second. And the latency is very small for like a star network. But then on a mesh network, it can still be very small if you can have mains power for every device that they can be listening all the time. Or then you need to kind of trade power for latency, and if you have power saving features, then the latencies, of course, vary. That is the recipient for that message currently listening or not. Mesh network, very key concept in the standardization, seen for the self-healing and self-load balancing features that can be achieved. So, of course, the network extends itself with every node added in a mesh network. The range increases, but also the error correction that if there is a change in the environment and a radio link goes bad, then the devices can scan for additional or alternative parents and switch the routing mechanisms. And in DECT NR+, there is the possibility of adding multiple border routers or gateways to the network. So that's like self-load balancing thing that you add a gateway and the network starts to form around that gateway, and devices can start switching to that gateway to take burden off from the existing gateway in the network. And very briefly, what this is from Nordic perspective. So Nordic has LTE-M and narrowband IoT modems, these NRF 91 family SIPs. And what this DECT NR+ at the moment is an alternative software for these modems. So you replace the cellular modem functionality with the NR with the DECT NR+ functionality. And what we have now is these 3 SIPs. So we support DECT NR+ on all the 91 family SIPs. The 51 is coming soon, any day now, as the newest addition to this family. And some like starting points for the NR+, that why was it done and where are the strong points for this technology. So this is like the 5G requirements triangle, where you have like the mobile broadband, which is basically the current 5G modem offering is mobile broadband, huge bandwidth, fast downloads and uploads in mobile phones and other cellular modems. But 5G has these other use cases for the massive machine type communication and then ultra reliable low latency communication, which are more IoT usage, so Internet of Things targeted use cases. In MMTC, the aim is that you can have thousands, tens of thousands, even 100,000 devices per square kilometer. And you can run different kind of sensor networks, for example, in urban environment where you would end up with a huge amount of devices in small areas. So that's the massive IoT space. And then the low latency communication, which is more like industrial control. And in traditional sense, it's like private 5G networks. So now DECT NR Plus is like the non-cellular alternative here. So you don't need a subscription per every device, but you can have the subscription in the gateway out of the network, or you can have networks that are not connected to wider internet, for example. And NR Plus fulfills the requirements that were made for 5G technology on these areas of machine-machine type communication and ultra-reliable low-latency communication. Those are a mouthful to say. But 5G, so it is called non-cellular 5G technology, and that's the reason that we do fulfill those requirements. So we can say that it is a 5G technology, but the non-cellular there is very important distinction. So some of these applications that are well suited for this technology. So smart buildings. So this goes a bit beyond like the smart home. The smart home is very much like consumer thing where you would need the same technologies that are in the mobile phones. But smart buildings, large buildings, office buildings, management, building automation, DECT NR Plus and the mesh networking is seen very good there to cover the possibly very large buildings. Smart city, street lighting, and the street lighting kind of creating the very extensive network to add sensors. Very good technology there. You can have a huge amount of nodes, big networks, and you avoid the subscription cost for all the devices. Smart metering is a strong focus point for DECT NR Plus. So smart metering does require a bit more bandwidth when the meter reading frequency is increased and more like quality data is read from the meters. So DECT NR Plus and the bandwidth and the bit speeds could match there. And then professional audio. So this comes from the classic DECT side, which was very much for audio applications. So on professional audio, DECT NR Plus with the new radio technologies and modulations, it does provide quality improvements. So professional audio is also a good application area for DECT NR Plus. And then a few slides of what do we have now. So we have at the moment only the PHY level implementation of the software, which is the lowest level of radio communication. We do have partners providing full stack applications. So Wirepass focused on smart meters and IoT applications has extensive offering already with the 5G mesh, with a long history of mesh technologies on other radio technologies that have been ported now for DECT NR Plus. Then we have Link Networks in the US with the Raven Mesh product, which is tactical headset and kind of enterprise headset applications. So audio over a mesh network, increasing the coverage and making error-free audio transmissions. And what we have as a modern, more recent addition from Nordic is that we have this API available in the Connect SDK 2.7. So this SDK came out in early July. And we have the API there that can then be used to build applications for the DECT NR Plus. A bit more about these partner offerings. So Wirepass 5G Mesh They have their own SDK, and this software needs to be separately licensed from Wirepass. And Wirepass focus areas are smart energy and smart electric meters and smart city applications, also smart building applications. The main thing there is that at the moment the stack is built so that it relies on the devices having mains power. So it's not trying to conserve energy at all. It's listening all the time. And that is done to minimize the latencies in the mesh networking. But for these kind of applications, it's very good stack, tested on sub-gigahertz and Bluetooth radios and ported to DECT NR+. Link networks, it is a tactical headset, so it's battery operated. There is some conserving of energy, and that has like its own requirements for the application, that how fast can that audio traverse the mesh network. But it is a product that is now in certification and will come out this autumn. And it is used in tactical headsets and also in these kind of enterprise environments. And if we look at these kind of applications that I mentioned earlier, where are these partners best at, then you can see that the Wirepass is for this kind of IoT use cases, and the Link Networks is currently for this kind of professional audio things. Also, Link does have support for, let's call it more real-time sensor networking. So IoT applications are also possible, but there are differences there with the bit speeds available on that kind of mesh operation of the Link network. Just a brief mention here on the DECT NR+ sample, which is part of the DECT of the Nordic SDK for 2.7. So the SDK, it has some documentation, it has the API help documentation, and then there is this kind of simple application that shows how to send and receive messages basically on the PHY. And this is the demo that we will show in the end, how this application is compiled, flashed, and how does it look like when you run it on this Nordic dev kits. So a bit more details on what we have now on the hardware side. So that was about the stacks offerings from us and partners. And this is the hardware that currently Nordic is the only provider of DECT NR+ hardware. Like said, it is for the 91 family. All the SIPs can be reprogrammed with the DECT NR+ modem software. And the 91 family is or all of those family members. Family members, they have this dual core kind of approach, that there is an application ARM Cortex processor, and it has flash and RAM memory. And then there is the separate modem core that runs either the LTE modems or, for our case, the DECT NR+ PHY. And there is like a API supported in the Nordic SDK based on Zephyr operating system, how to use the modem side. The 61 is readily available, has been around from late spring. The 31 is a variant of this SIP. it is smaller and a bit cheaper because the power management and the crystal is taken out of the SIP. And this is a good fit for DECT NR Plus for these kind of IoT use cases. If you have the mains power, then our battery operation optimized PMIC is kind of overkill. So in 31, that PMIC can be replaced with other power supply means. And the crystal is also selectable, so some variation in the crystal is allowed. And this is possible for DECT NR Plus because the certification is simpler. And for LTE, if you replace the power management or the crystal, you need to do all the full LTE cellular certifications, which is heavy going. But for DECT NR Plus, the certification is much simpler, and it makes sense to save the costs for products using the 31 SIP. The 51 is coming soon. We were kind of hoping that it's available when we planned these webinars, but there was some quality fix issue and it is delayed a few days, but it is coming out early September. And it is very similar on the application core side. So all of these family members have the same kind of M33 application core for the applications. And then there are some changes on the radio front end on the 51 that makes it a bit more cost optimal than the 61 in the usage. We have development kits available. So for the 61, there is the development kit that is already available at the resellers. And the 51 development kit is coming early September to the distributors. So some words about the regulation. This is the DECT band world map. So the blue color there is where DECT band is defined and can be used. So like I said, this is very interesting, especially for Europe, where we don't have sub-gigahertz bands available like they do in the North America. So the DECT band, DECT technology is an European Union harmonized standard. So it's available in every country in the European Union. The certification standard exists, and it's going through the EU publication into the official journal. And we think it will happen this autumn as well. There have been some information exchange with this publication. But it can already be used with these certification labs, and they have this kind of notified body that signs the results against this standard, and it can be sold in the EU. North America is a bit different. The DECT band exists there, but the DECT band certification is harder to pass. So FCC has regulation, which is basically technology independent, but it has roots in the old classic DECT operation. So in the test standard, there are strict timing requirements. And in the US, the TX power, so the transmission power, is limited to 10 dBm, which is half what is available in the EU. And so the usage of DECT band and the kind of making mesh networks is harder in the US for the DECT band. And this is why we are introducing with the 9151 SIP the possibility of running DECT NR Plus on the North American 915 megahertz band. So this will come in a product variant of the 9151, which is estimated now end of Q1 25. And some early access software is available end of this year. So that takes the DECT NR technology as it is and runs it on the 915 megahertz band in the US and Canada and Mexico. So North America. The band is from 902 to 928 megahertz. So it's a good wide band. And there are other applications there, but we see that the DECT technology coexistence mechanisms are a good match. So it can be used there. And that makes it easier to certify products which are DECT technology, but they are certified for this 915 megahertz band. And that has like the band specific regulations, how to certify there. And then we go to a live demo that is run by Heidi.
So now I'm going to demo how you can get started with the DECT NR Plus sample that is available in NR Connect SDK. So to do this yourself, you're going to need the NR Connect SDK installed on your computer. You will need version 2.7.0 or higher. And then you're going to need Visual Studio Code with NR Connect for VS Code extension added. You're going to need the NR Connect for desktop installed on your computer. And then you're going to need the DECT NR Plus PHY modem firmware. This is a binary file that will run the DECT NR Plus physical layer on the modem core of the device. And this is distributed through Nordic sales. So you will need to get in contact with them to get a hold of this. And then lastly, you're going to need 2 NR Plus capable development kits. So the NRF 9161 development kit, which is available now, you can use. Okay, let's get started. So the first thing we're going to do is we're going to flash the DECT NR Plus PHY modem firmware to both of our development kits. To do this, you're going to need NRF Connect for desktop, and we're going to use the programmer application. So open that up. This is what it looks like. And now we want to connect the 2 development kits to the computer, and then we're going to turn them on. And they should appear here in this drop-down menu. Here we go. So we're going to select the first one, the NRF 9161 DK. Then we're going to add file, browse, and then we're going to navigate to where you have stored the DECT NR Plus PHY modem firmware. So it's going to be, and it's going to be a zip file. So here it is, the latest version 1.0.1. Open. So zip file is selected, and then we're just going to hit write here. And this warning message can be ignored. This is just because the DECT NR Plus modem firmware doesn't adhere to the pre-programmed kind of file that the programmer expects. We click write. And then we just wait a few seconds. There we go. Close. And then we're just going to do the exact same thing with the NRF 9151 DK that I have. So here we can see the zip file is already selected. We don't have to find it again. And then we just select write. Write again. and wait a few seconds. There we go, close. So now both of the DKs are running the DECT NR Plus physical layer, a hello sample to both devices. Now there are two options for doing this. You can either use the programmer application if you have pre-compiled binaries and then just flash those directly to the devices. You can find the pre-compiled binaries in this blog post, Getting Started with NR PHY, down here. Using the programmer application, here are both hex files. But we're not going to do that. We are going to build the sample in NR Connect SDK and then flash it in Visual Studio Code. So open up Visual Studio Code, and then we are going to open a folder, and we are going to open up wherever you have installed v2.7.0 or NR Connect SDK. And we're going to open that up. So here is v2.7.0 of NR Connect SDK. And then we are going to find the sample. So go to NRF and then samples, DECT, and then under DECT PHY, hello DECT is the directory where the sample is located. So here we have the application that we want to flash. So notice that there are two overlay files here for the configuration. There's one for if you're in the EU, and then there is one for the US. So this one just sets the kconfig config carrier, which is the carrier being used, to 1677, which corresponds to DECT band number 1, which is the DECT frequency allocation in Europe. And then the configuration for the US sets the carrier band to the DECT band number 9, which is the band allocated in the US. And here we're also setting or limiting the TX power to 10, which equates to 10 dBm, while the default TX power is 19 dBm. We can see more about this if we go to the kconfig file. Here we see TX power. There's a range from 0 to 13. 13 equates to 19 dBm, which is the maximum transition power that you can get. But then in the US, that is again limited to 10 dBm. So now we're going to right click on our sample, and then we're going to go down here to the NRF Connect, add folder as application. And again, you need NRF Connect for VS Code extension installed in Visual Studio Code, and then you will have this window here that we can go to. And here is our application. I can also see there are some, we're using a 240 toolchain. That is incorrect. So we're going to set the active toolchain here to 2.7.0. Perfect. And then we can also refresh the SDK. Okay. Now we're going to add a build configuration. So first I'm going to add a build configuration for the 9161 DK. Make sure under board target that compatible boards is selected, and you will only get the boards that the sample supports. If you select Nordic boards, you will get all Nordic boards. So we're going to select the 9161 development kit. We are also going to, under extra kconfig fragments, we're going to select a fragment, and then we're going to browse and find the overlay file. It is very important to add an overlay file, or at least you need to set the kconfig config_carrier to something non-zero, because the default value is 0 and then the application won't run. So we're adding EU because I'm in Norway right now. Okay, great. And then we're going to scroll down and we're going to select build configuration. And now we're compiling the application. Let's wait for that to be done. Okay, that's done building, and it builded successfully. Before we flash this, we're also going to add build configuration for the NRF 9151 DK. If you're only using the 9161, you don't need to do this. So now we select the 9151, and then under extra kconfig fragments, we're going to add this one again. Perfect. And then build configuration, and then we wait once again. Okay, perfect. And now we have both. We have the application compiled for both boards. Now we're just going to go down to connected devices. We're going to select first the 9151 DK, and then select flash 9151 DK. Wait for that to complete. Thankfully a bit quicker than the compilation. Perfect. And then select the 9161 DK, flash to the 9161 DK. Perfect. Now let's get up some terminals for these devices. You can use the terminal in Visual Studio Code. Just go here and then select the correct COM port. Connect. And then it should show up. But I prefer to use the serial terminal application in NR Connect for desktop. So we're going to open 2 instances of this application. Here we go. Perfect. Here we're going to select one of the devices, and then we're going to select the other one. And we're going to connect to port. There we go. And there. Okay, and then let's reset both these devices. Let's see. Okay, so now we can see both devices are transmitting a payload of incremental counter starting with 0 to 1 to 2, and then we can see here that the other device is receiving it, and we also get the RSSI value of the connection. And this is pretty much it. You can take the devices, walk around with them, you know, test out the signal strength. You can take the application, use the NR Plus API that is an NR Connect SDK, and make your own application. Thanks for watching.
Then we are in the questions and answers phase. We are a bit behind schedule, but let's start taking the questions here. I'll start from the top of this list. Any plans to support both NR Plus and LTE-M in the same firmware? So this requires a much more capable hardware than we are currently having with the 91 family. So this is something that we can look in the future, but it does require some heavy lifting hardware processing power to run those both. Is there a DECT band for Australia? Happy news, there is. And Australia actually has 20 megahertz band for indoor and outdoor, and then a separate 20 megahertz for outdoor applications, if I remember correctly. So it was very new addition, a change in the channel plan that was done in Australia for the DECT bands, around 1.9 gigahertz. These keep on jumping up and down as the questions come in, so I got lost where I am. Does the current firmware support full duplex? It's half duplex. So you send and then you switch to receive mode. Half duplex communication. Pricing, I'm not able to answer. It depends on the applications and quantities. Do you think it will be possible to use DECT as a transport for other protocols? Yes. So IP over DECT is being standardized, and then DECT is like a generic transport, so you can run additional applications on top of it. And for smart metering, there is the DLMS COSEM being run over DECT NR Plus. How does the power consumption compare with NRF52? So it is higher. It is on par with the cellular world. It's the cellular modem, and the transmission powers on are like 20 dBm. So that's double what the Bluetooth transmission power basically is. Can you tell us if and when the DECT NR PHY modem firmware will be freely available? So we cannot give a date on this, and this is linked to the certification and regulations that exist in the world. So the hardware, because we have a PHY only, we can't really provide a certified DECT NR Plus modem. And because this is an alternative modem firmware for products that are basically LTE devices, we would need to certify with both, and that we can't do. And to limit this kind of regulation hassle, we can only give this DECT NR Plus PHY as a limited accounts with customers that are basically authenticated, and that means going through Nordic sales. But we do have it in the sales. It's freely available through the sales, so we don't sell it, we distribute it in this access controlled manner. China and India, both countries, there are discussions how to use the 1.9 gigahertz band, and that is run in the DECT forum, and people interested should contact DECT forum and join the work. So there are work groups working in both countries, talking with the regulators. Is Nordic intending to provide any layers above the PHY layer? Yes, we are. I mean, it's a PHY, so yes, we are working on the MAC layer and beyond, but it is a bit slow going at the moment. But yes, we are working on those ones. But if you have, let's say, application need within a year, then be in contact with Nordic sales on early access to like a Mac level that we are working on. It is a subset, so it depends on your application if it's applicable. And then for these kind of bigger applications, tested stacks, there are those partners offerings. Similar question there. Does the firmware have routing capability? So no, we don't have routing capability at the moment. It's a PHY level. And working on the MAC level, the MAC is not a routing layer either. The MAC will help constructing the network. So you make the associations between devices using MAC functionality. But then the routing of messages and that is still on the application level. And because we don't do the routing, then yes, it is possible to use 6-low-pan kind of routing options, but it does require own development. We don't have drivers for Linux kernel, but it is perfectly possible and still, yes, requiring a bit of own work to add 91 family device as an interface in Linux and map those Linux network interface operations to the operation over the DECT NR Plus. What distances do we reach with DECT NR Plus? So we have reached 6 kilometers line of sight, and that's kind of the maximum. In urban environment, like down the street, 400 meters. And then it varies, of course, a lot if you have to go through buildings and what kind of buildings and wall materials there is. But hundreds of meters in urban environment from indoors to outdoors is possible. Another Linux kernel question. Can the mesh latency be lowered below 10 milliseconds? Sorry. Yes. So if you have the radio on all the time, receiver on all the time, you can forward the message knowing that that associated device is expecting, it's listening on the channel that it has reported. Of course, there may be some other radio transmissions that will block your transmission going through, but it's possible to get like 10, way beyond 10 milliseconds to the 1 millisecond range, but it depends if it's like a mesh and are there other transmissions happening from other nodes. Does the switching back and forth between LTM and DECT NR? So we do not support this kind of switching between the firmwares. Sorry, I'll take a glass of water. You need to flash the whole modem software to switch between these firmware modes. And flashing the modem software is a heavy, expensive operation. So, I mean, this would be needed for like a gateway operation, but for gateway, you need basically the radio on in both technologies all the time. So you need 2 modems for the gateway. And yeah, I mean, otherwise it gets really complex with the timings and kind of network establishments, connection establishments, running or trying to run 2 different technologies on one radio. Range we already discussed, and audio applications. So we have a PHY, so it's perfectly possible to run audio or IoT like we have our partners doing on top of that PHY, but there is work needed to be done in the application. Like, do you reserve like scheduled access with reserved bandwidth, or is it more like mesh best effort kind of operations? Those depend on the application also for audio side. So it's possible, but requires own development work at the moment. So the first question, do I need a SIM? So no, this is subscription free, so there is no SIM. The dev kits do have like SIM slots because you can run the LTE-M modem there, LTE-M or narrowband IoT modem there with the SIMs or soft SIMs or whatever. But the DECT NR Plus technology doesn't use a SIM. Has audio been demonstrated? Yes, it has been. It uses what we call scheduled access. So there are the radio channels, and in those channels, there are time slots. So you can kind of make like a persistent reservation on a time slot, scheduled access, and then you use that time slot on every frame to send your data, or multiple time slots. It is certainly possible and has been demonstrated. What is the maximum range in star topology? So the range, always asked and very, very hard to answer because it depends so much on the environment. In the EU, so with the higher transmission power, we have reached 6 kilometers line of sight and 400, 600 meters in urban environment. And the 400 meters was basically that it was from indoors to outdoors. Now in the US, if you use the DECT band, nowhere near those numbers because the transmission power is halved. But that's why we have the 915 megahertz band support coming. And there you can use the same kind of transmission power and even more on the band, but that requires like a amplifier solution then. So kilometers. easily available. How are PHY packets differentiated between the different stacks? Well, first of all, of course, there are like network IDs that differ for networks. So it would be very surprising to have like an audio network and building automation network using the same network ID. So they differentiate the packets themselves, that every PHY packet has the network ID in them. And then there are these kind of least interfered channel usage, interfered slot avoidance, so that there wouldn't be accidental overhearing of the different networks. But those are differentiated on the PHY level already, so not a problem on the higher levels. A long question on basically comparison with the technologies. Huge list of technologies there. Well, let's start with like LoRaWAN, Sigfox, MIOT. I don't know how you pronounce that, but that's how I pronounce it. Those are much narrower band. So you can get like kilobits per second. Like in LoRaWAN, in the worst case, when you're far away from the base station, you have 50 bytes an hour. So that's really, really tiny bandwidth. So DECT NR plus bandwidth is much, much bigger. We don't get that kind of distance like, for example, LoRaWAN has. It has a huge link budget, 160 dBm. With DECT NR plus, we have like 130 dBm. So less range than those technologies, but much more bandwidth. And with the mesh forwarding, you can extend the coverage. So you kind of pay with bandwidth for the range in mesh networks. Wisdom, I would also put in this bracket that most of the Wisdom variants, like it has tens of PHYs defined, most of those are narrower band and less transmission power that can be done on the DECT NR plus. Of course, Wisdom is like a mesh technology in itself, so it has a lot of same features. But then when you compare these run on the sub-gigahertz bands, so sub-gigahertz, I would say, is very much like a US thing, that you have this big bandwidth of 902 to 928 megahertz, so almost 30 megahertz of band. And for example, in the EU, there is no such thing on the sub-gigahertz. We have 6 megahertz band in the sub-gigahertz range. And that is limited with 200, 400 kilohertz channel bandwidth. So you can't get the same kind of bit speeds in the EU like you can have in the US. But I would say that that's the kind of biggest thing, that DECT NR plus has like a sweet spot of the speeds and range in the US on the 900 band, and then in the EU in the 1.9 gigahertz band. And it makes it a really nice technology, a bit of a compromise between all of these different technologies. Like Wi-Fi has like a huge speed, but of course it's on the 2.4 or 5 gigahertz, which are pretty full already and hard to use in like industrial environments, because there are so many mobile phones and Bluetooth headsets and whatnot on the ISM band. So publicly, this hasn't been compared, I think, because DECT NR plus is such a new technology. So it hasn't been compared with these other technologies. There are some academic papers on the DECT NR Plus and so on. Is it possible for the same 51 to communicate in DECT and LTE? So yeah, like I said, that you can't run them concurrently. There is no processing power or space to run those stacks at the same time. And to answer this latter part of the question, that how can you then combine like two modems, then any data coming from the DECT network goes to the application core, and the application core can forward that data over a serial or bus to another SIP application core, where it's received, and then it's given to the LTE modem and sent to the cellular network. So the connection is pretty easy to do on the application core. In the same device, they are connected with serial bus. Is there a sniffer available for picking up PHY packets? So there is no sniffer by itself, but you can, like we have a PHY API. So if you do not set the network IDs and everything there, then you can receive anything that is sent on that radio channel with the PHY API as it is. So you can see all the traffic that happens there. It's not directly linked then to any like Wireshark or any sniffing applications, but that's let's leave it for the developers to do. The cost I will skip. I have no memory for for dollar numbers, and it depends on the amount of SIPs needed and the devices counts and so on. So our sales is very happy to help on those kind of questions. Power management, is the NPM 1300 good companion? Here I also forward you to sales or the dev zone. So I'm very much focused on the DECT technology, and I can't remember the PMIC specs that does it support 9131. There is a PMIC that does support 9131, that is for sure, but I can't remember if that is the number. Is 900 megahertz better compared to 1.9 gigahertz to achieve range and building penetration? So yes, two things there. So lower frequencies, the physics say that they penetrate better. So the lower frequencies do penetrate better and go further in the real world. But the bigger thing here is that for the 900 megahertz band, there can be used much more transmission power than on the 1.9 gigahertz. So of course that transmission power translates to penetration and range. It's usable in the UK. So although UK sadly decided to leave the EU, they still have a lot of the EU regulation. So yes, DECT band is defined for the UK, the same as it is for EU region. The slides will be available, and this is recorded, so it will be added there. So yes, the sniffer can be built on top of the PHY API. That's that was answered. The thing in 91X. So thing in 91X and the 51 are, yes, they are planned to be released, and they should be released in a few days, I would say. So early September. We thought that the 51 would have been already released, but there was a quality thing that needed to be fixed, but it is now days away. The 9131 evaluation kit is available from Nordic at the moment. It's not available from the distributors because there are issues with like the software support. So certification of the LTE side, or how do we give this kind of DECT PHY with it? But it is available if you ask the Nordic sales. Do you have plans for expanding the protocol stack? Yes. So we are working on it. It's frustratingly slow from my perspective as like a technical manager. So there are so many things to do on the cellular space that we are fighting for the resources. But we are working at the MAC layer now. And how far up the stack are you planning to go? So the MAC will be a release in itself. But of course, we are aiming to go the full stack of DECT NR Plus and the IP stack on top of that. So you would have like UDP sockets and possibly TCP sockets available. But that's way into the future. For FCC, can product side declaration on conformance by Nordic certifications in order to BLE? So at this moment, this is not possible as I understand it. So BLE has its own ISM and Bluetooth SIG defined conformance and testing. Now this DECT conformance testing that we have done has been in the EU, so it's not usable as itself in the FCC. And I would recommend going to the FCC with the 900 megahertz band thing instead of the 1.9 gigahertz band, which is harder to certify. But we can't certify there because we don't have the medium access control and we can't pass the medium access tests because those would require the future coming MAC layer. How many channels in the 1900 band? So in the EU, there's a 20 megahertz bandwidth, and it has 10 bands. In the US, it's 5 bands because the frequency is from 1910 to 1920 megahertz. How can you get the modem firmware? So you need to ask Nordic sales. So there are certification issues for these devices that we can't give like a totally different radio technology to run on the same SIPs and dev kits. So we need to have some kind of access control for giving the DECT modem firmware. And it can be, you can get it from contacting Nordic sales. So we don't sell it, we give it for free, but we need to have some kind of access control and knowledge who is using it. How many devices can be connected in a star network, and what is the limiting factor? The limiting factor is always in star and mesh, it is the application communication requirements. So if you have applications that need certain latency and need to use a certain kind of, or need to send certain amount of data, then you can calculate like the worst case if they need to do it all at the same time, that you still meet those latency requirements with the radio bandwidth. But if you have applications that send relatively little data and are not in a rush to do it, then basically the limit is memory management, that you can keep all the devices in the central hub memory in a star network. In a mesh network, that also is extended, that it's the child devices that have the further on devices in their memory. But it is the application communication need. the hub or the sink, the gateway radio link is the bottleneck of the system, and that kind of sets the limits for the applications and device counts. How far are you from releasing the Mac layer? Okay, so we will have like early access program for the Mac layer first quarter next year. And then when we know that it works, it can be expanded and given for general access, but it is next year. What is the maximum payload size in bytes? So this depends basically on the distance and like the radio link quality that you have between the devices. There are 4 or 5 different modulation and coding schemes that we currently support. And on the highest coding scheme, we support 4 time slot transmissions, and if I remember correctly, it's 5,600 bits in that one transmission. So let's say 600 bytes. The math escapes me when I'm trying to speak English at the same time. So the one transmission could be 600 bytes, and of course you can do multiple of those. That's in one frame. So in 10 milliseconds, 600 bytes. And if you have the radio access, then you can do it again after a short wait. Schedules, channels, what is the minimum interval possible? A very hard question. So if you need to send and then switch to receive, it takes a bit under one time slot at the moment. So one time slot is 416 microseconds. So if you need to send, then you have one slot gap, then you can receive. And then, of course, it depends on the amount of data, that how long you do it. And then when you switch back to TX, then it's one slot once more. We are working on improving these turnaround times, but that's the current situation. And end of this year, like I promised, there will be early access to the 900 megahertz band with a new software release. Then we should be in the sub-slot interval, so 208 microseconds between TX and RX. And that's it for the questions. Thank you all and have a nice day. Bye.